All right, everybody, let's get into our energy pyramid notes. We are going to start by labeling the 4 trophic levels on our energy pyramid. Before we do that, we're going to write what the heck a trophic level is. And instead of writing out the word trophic level 4 different times, we're going to abbreviate it by doing a TL and then just write off to the side that means trophic level. And again, trophic levels are these different stages on our energy pyramid. So as we're filling in these notes today, we're going to be identifying the differences on each level and how the energy is transferred from one level to another. For our first trophic level, that is located at the bottom. So you can do first TL, second TL, third TL, and fourth that's an L, TL. All right, so we have our 4 trophic levels. Going to the bottom, our first trophic level has to get its energy from somewhere, and where it's going to get its energy from is the sun. So go ahead and color in your sun. You don't have to be perfectly inside the lines, not a big deal. And then we are going to label our sun with the type of energy that we receive from the sun, and that type of energy is radiant energy. All right, so we get radiant energy from the sun, and that energy goes into our first trophic level. Now, since the first trophic level gets energy from the sun, we call those producers. Or we call the organisms that are found on this first trophic level producers. Another name for producers is autotrophs, which, as we discussed in our previous notes, autotrophs automatically convert radiant energy into chemical energy. So autotrophs is that unique name that we give to producers. And if you think about trophic level and autotrophs, that's a similar word. Okay, so we've got our producers, otherwise known as autotrophs, and then we're going to write an example of an organism that's a producer. And in this case, I'm just going to write the word grass because I'm just going to keep it simple, and that's going to be my producer for my example. All right, moving on to the second trophic level. The organisms on the second trophic level consume producers. And what's that word that we use for organisms that consume producers? It's primary consumers. And because primary consumers consume producers, they are not autotrophs, they are heterotrophs. And that prefix hetero means different. So our primary consumers have to get energy from different sources. They can't automatically convert radiant energy on their own. They have to consume producers to get that, to get energy from them, to get their stored chemical energy. Okay, our example in this case is going to be a mouse. You can change it to something different if you wish, but I'm going to say mouse. All right, producers get their energy from the sun. Primary consumers get their energy from producers. Remember that our producers are going to convert that radiant energy and convert it to chemical energy. When our primary consumers consume our producers, they get part of that stored chemical energy. Who consumes the primary consumers? That is our secondary consumers. And these guys are also considered heterotrophs because they have to consume other organisms to get their energy. And my example in this case is going to be a snake. All right, secondary consumers consume our primary consumers. And then who consumes our secondary consumers? That would be our tertiary consumers. These guys are also heterotrophs. And my example for this one will be a hawk. Okay. Looking at our examples, I've kind of made a food chain. Be aware that some of these, like the snake or the mouse, or the snake or the hawk, they might eat from other levels as well. Just how think about like a food web, right? We have a lot of different organisms and we're showing the flow of energy from one organism to another. Even though I'm showing these as a food chain, sometimes secondary consumers can also eat producers. Sometimes tertiary consumers can also eat primary consumers. So it's not always a straight linear line, but for our case today, it will be. Okay, now that we're done with filling in the middle, we are going to talk about the recycling of energy in our energy pyramid. So you might notice a little recycling symbol here. We've got our hawk, snake, mouse, and grass. They're alive. We'll pretend that they're alive, but eventually they're going to die, right? And there's going to be energy and nutrients inside of that organism when they die, and we have to return those nutrients back to the soil so we can reuse those nutrients to move forward again with our energy pyramid. So what do we call our organisms that help break down dead and decaying organisms? Those are, we call them decomposers. I'm gonna write the word decomposer. So these are decomposers, and you might remember examples. You can fill in the ones that you remember, but I'm going to write in fungi and insects and bacteria. So those are the three decomposers that I'm going to focus on today. How are they helpful? As I've already said, they're going to break down dead or decaying organisms. Those can be producers, primary consumers, secondary consumers, or tertiary consumers. They're not picky. As long as it's dead and decaying, they will help with that process, and they will return those nutrients from those dead and decaying organisms back to the soil, which means it directly benefits our producers. Okay. I'm going to do my best here, and you're going to do your best too. We're going to write down the function of these decomposers. And the function is to break down organisms to recycle nutrients back to the soil. And we're going to add this little note. Keeps the flow of nutrients in an ecosystem. All right. So I'm going to repeat that back in case you need to finish it up. Break down organisms to recycle nutrients back to the soil. So break down organisms to recycle nutrients back to the soil. And then our little footnote is keeps the flow of nutrients in an ecosystem. So that's our very helpful decomposers. While they're not on a specific trophic level, they play a very vital role in ecosystems. And again, we're kind of list them off to the side because they're breaking down dead organisms. They're not consuming live organisms. So there we go. Okay, jumping back into our energy pyramid, we're going to, we're going to go ahead and color in our little fire flames. You can use whatever combo of colors you like. I am going to use red and orange and yellow. And while you're coloring, I'd like you to think, what type of energy are these flames representing? So I'm going to get to that in a second. Okay. When we're looking at our radiant energy, so we've got our radiant energy, and that's what starts the flow of energy in our energy pyramid. From our radiant energy, our producers are going to convert it to chemical. So we can say that our producers get 100% of the energy from the sun, right? Because if we're taking in that radiant energy, of the radiant energy in this energy pyramid, the producers have 100% of that. Okay, now moving on to the next level. So primary consumers consume our producers, but they're not going to get 100% of the radiant energy. They are going to get 10% of that radiant energy. And let's talk about why that is. So up over here, I'd like you to write down that 10% of an organism's energy is passed on as what type of energy? Chemical. So 10% of an organism's energy is passed on as chemical. So we've got the grass is 100% of their energy from radiant. They converted it to chemical. But the mouse is only going to get 10% of that original energy. What happens to the other 90%? Well, 90% of an organism's energy is used as thermal energy. So that's why we have the little flame over here. 90% of the energy is going to be used up by the organism by its living its life processes. So for the grass, through going through tropisms, through growing, the mouse will use 90% of its energy hunting for food, hiding food, running away from predators. It's going to be using up 90% of the energy it gets in the grass just doing mouse stuff. So it's used as thermal energy, which is body heat, or mechanical energy, which is just moving around. So that is what happens with our energy flow through this pyramid. Now the snake eats the mouse, and the snake is only going to get 10% of the energy that the mouse had. So when looking at percentages of from the original radiant energy, what's 10% of 1? 1%. So of that original energy, the mouse, I'm sorry, this is a snake. The snake is going to get 1% of that energy from the mouse. And then moving on to our fourth trophic level, of that original 100% of energy, the hawk gets 0.1% because it's only going to get 10% of 1%. And that might sound like, whoa, that's a lot of numbers going around. So let's break this down again. Radiant energy, our producers get 100% of their energy from radiant. They will pass on 10% of that energy to our primary consumers as stored chemical energy. The primary consumers pass on 1% of that energy to the secondary consumers, and then the secondary consumers pass on 0.1% of that energy to the tertiary consumers. Again, 10% is passed on as stored chemical energy that remains in the mouse, remains in the snake, but 90% of the energy that the mouse consumed from the grass is used up with the mouse doing life processes. Same thing with the snake. Only 10% gets passed on to the hawk because 90% of the energy is being used up by the snake from hunting and just living its life. Okay, that's it for these specific notes. The next thing we're going to do is, that I'm just going to recap on, you don't have to write it in unless you want to. So I'm using a pencil, but feel free to write this in as you want, if you want to. When we're talking about total units of energy, let's say, I'm just going to throw out a number. Let's say there's 1,000 units of energy in the grass in this energy pyramid. How many units of energy would go onto the mouse then? So if only 10% of the energy goes onto the mouse, how many units of energy would go onto the mouse? That would be 100 units of that energy. I think it's like kilocalories or something like that. So 100 units of that original 1,000 would go onto the mouse. How many units of energy would go onto the snake? That'd be 10. And then how many units of energy would go on to the hawk? That would be 1. So that's again showing you that 10% rule where, so this, I picked 1,000, but let's say there's 1,000,000 units of energy in the producers in the ecosystem. You would still only pass on 10% of that energy to each level. So, all right. If you have any questions, you're going to ask your teacher. I hope you have a great day. Peace out.